The ozone layer is our natural barrier in the stratosphere, protecting life on Earth from harmful ultraviolet UV radiation from the sun. Chlorofluorocarbons, or CFCs, are chemical compounds that contain chlorine, fluorine, and carbon. CFCs were first developed in the 1920s, and it is widely used in various products such as refrigerators, air conditioners, and aerosol sprays due to its stable and non-flammable properties.
So we know the Montreal Protocol was a huge success. This was signed in the late 1980s when scientists and policymakers from around the world gathered together to try to save the ozone layer.
The chemicals they regulated persist in the atmosphere for many decades. They thin the ozone layer and they create a seasonal hole over Antarctica. They basically take away part of our planet's natural sunscreen, and that increases the risk of skin cancer and damage to plants.
However, in the 1970s, scientists discovered that CFCs released into the atmosphere could reach the stratosphere, where UV light broke down these molecules, releasing chlorine atoms. These chlorine atoms then react with ozone molecules, O3, destroying them and reducing the concentration of ozone in the atmosphere.
There are some industrial compounds that are not banned by the Montreal Protocol, but as they enter the atmosphere, they will also hurt the ozone layer.
But the unregulated compounds have a short lifespan in the atmosphere, unlike the chlorofluorocarbons that were originally regulated. So they have a short-lived impact on ozone, and we don't think they'll delay recovery by more than a few years.
Reducing ozone in the stratosphere increases the amount of UV radiation that reaches the Earth's surface. Excessive UV radiation can cause skin cancer, eye cataracts, and damage marine ecosystems and plant. This discovery prompted a rapid global response. In 1987, the Montreal Protocol was signed, requiring the gradual reduction and eventual elimination of the production and use of CFCs and other ozone-depleting substances.
And the really big uncertainty in ozone layer recovery is climate change. There are many naturally produced ozone-depleting substances that are emitted by the oceans. And as the oceans continue to warm due to climate change, those emissions will increase, and that will further delay ozone recovery.
Thanks to international action, the production of CFCs has decreased drastically, and the ozone layer is showing signs of recovery. However, there are still challenges from remaining emissions of CFCs and new chemicals, such as hydrochlorofluorocarbons, HCFCs, and hydrofluorocarbons, HFCs, which, although less damaging to ozone, still have negative impacts. NASA and other space agencies continually monitor the ozone layer and emissions of ozone-depleting substances using satellites and field research. These data are critical to understanding atmospheric dynamics and ensuring continued ozone recovery work. Protecting the ozone layer is our shared task. By continuing to support environmental policies and reducing the use of dangerous chemicals, we can ensure the Earth remains protected from dangerous UV radiation.